So today we're talking about exponential functions and their graphs, and we're going to talk about two types, exponential growth and exponential decay. Let's take a look at what each one looks like in our calculator, and we're going to draw a quick sketch of that. So here we go. We're going to plug y equals 2 raised to the x into our calculator, and we're going to take a look at what the picture looks like. And you see that? Watch this. You see it starts off real low and then just takes off like a plane or like a jet or like a rocket ship, right? Like a spaceship. That's exponential growth. And what are we going to do? How do we sketch a picture of that? If you're just sketching it in your notes, you sketch a picture like this. Label the axes, x and y, and then we're just going to draw a brief little sketch of it. Doesn't have to be perfect. All we want to do is get the picture right. That's about right. We're good to go. Leslie asked a great question. She says, why did I draw an arrow at the end of it? According to the calculator, it looks like it just stops. Well, check this out, Leslie. We're going to zoom in for you. Zoom in. We're going to zoom. Like, let's take a look right over here. In fact, it's not stopping. It's getting infinitely close to this line over here. Right? It looks like it even stops right here, doesn't it? Let's zoom in again, and let me show you. I mean, it's getting ridiculously close. Whoops. Do you see it? You see, it's getting really close. Do you think it's ever going to touch that line? Turns out it's not going to touch that line. It's going to get closer and closer and closer. I mean, like ridiculously close to the x-axis, but it will never actually get there. And that idea, does anybody know the vocab word for what happens when you approach a number or approach something but never actually get there? Yeah, I heard it. And we're going to take it down in a minute. It's called an asymptote. It's called an asymptote. In fact, let's just take that down now, and then we can draw a picture of exponential decay in a second. Let's take a look at, come on now. Let's take a look at what exponential decay looks like. All we're going to do is look at a picture. And so hit the graph button. Exponential decay looks exactly like the opposite of exponential growth. And so let's write that down, or draw a picture of it. Right? It's just going to draw a sketch. What happened? Whoops. X, y. Here's an example of exponential decay. It's going down like that. And it's never going to cross that line. So let's talk. Let's talk for a second about asymptotes, about lines. You know, I told you, and Leslie asked an amazingly great question, that, you know, and we had to look at it. It turns out this graph is never going to break past this line. So y equals 2x will never break this line. Does anybody know the equation of this line? What's the equation of horizontal lines? Is it y equals or is it x equals? It's y equals because every coordinate on this dashed line has the y has 0 for its y coordinate. And hence we'd say this is the line y equals 0. So what's the asymptote? What's the equation of the asymptote for that graph? Nope. It's just y equals 0. And so we say, since y equals 2x is never going to break through that line, y equals 0, we say that y equals 2x is asymptotic about y equals 0. Just means it'll come really close to y equals 0, but it will never actually break through it. Okay, hold on. So Ariella asked a great question in that she said, what about this graph over here, the decay one? Is it going to break through this line? What do you guys think? No. Nope. You could check in your calculator if you want. You could look in the table of values. You could keep zooming in if you wanted. It's never going to break past that. So what's it's asymptotic about what? What's the equation of the line that it's asymptotic about? Yeah, so you could say it's the same as the other one. It's asymptotic. Whoops. Oh. It's asymptotic about y equals 0. So here's what we're going to attack next. I'm going to ask you to sketch a graph, estimate how much it's worth, sketch a reflection in the y-axis, write the equation of the graph after its reflection, and then figure out the asymptotes. So our first one, we're going to sketch. We just sketched a graph. That was easy, right? The second part, estimate. Use your calculator, or you could do as Julia said. Julia said, well, 3 divided by 2 is 1.5. And 1.5 raised to the 1.2 is like a little bit more than 1.5. And so how much does it come out to be? Yeah, Julius, you were dead on, man. Dead on. That's very impressive. Very impressive. 1.2 is approximately, that's what those squiggly lines means, like 1.6. And then part C, we're going to need to reflect. Reflect that in the y-axis. So which way does it flip? Does it flip left and right, or does it flip like up and down? Left and right. It's like it swings around the y-axis. Swings around the y-axis and suddenly becomes an exponential decay. Yep. There's that one. How easy is this? Oh my God, it's cake. Butter cake. Vanilla cake. It's red velvet cake. Love red velvet. Okay. And the hard part. How do you figure out an equation for it? Any ideas? Leslie, what are you thinking? Any ideas? You are amazing, Leslie. That's exactly what you do. You flip the original. So instead of it being 3/2, it's 2/3 to the x. Another way that you could think of doing it is that, and this isn't a word, I just came up with it. What you did was you negatized all the x values. Any x values that were positive became negative, flipped to the other side, and any x values that were negative, you see this like, do you see this area over here? Became positive, so you negatized it. You know what I mean? Anything that was negative got negatized and became positive. I don't know, it sounds nice. Probably not, don't put that on the regents. But a way that you could represent that is that you could say, well, all the x values became the opposite of what they were. And the two make sense. Because before break, probably nobody remembers, anything raised to the negative power, what do you do to the stuff inside the parentheses? You just flip it. And finally, in each one of these cases, these equations are approaching a particular number or line. What's that line? Y equals 0. Oh, no, Bill. In each case, check this out. You see they're approaching you are right. They are approaching the fact that the x's, well, I'm sorry, not the x's. They are approaching the x-axis. And here's where things get confusing. Do you know what the equation of the x-axis is? Y equals 0. And that's so stupid, right? That confuses the hell out of everybody. That here it is, we've named this axis the x-axis, and its equation is y equals 0. It's so confusing to the mind. But that's because every point on that axis has 0 for its y coordinate. One last part of our lesson, and then we're done. We have 2 questions to answer, and the only reason that those 2 coordinates are, these 2 numbers at the end are circled, is because those 2 numbers at the end, they act like y-intercepts. They shift it up and down. And we're going to talk about that in a second. But first, take this down. And Julius. Julius, so check it out. Do you remember when you used to graph lines back in the day? Okay, so you remember it's like y equals mx plus b? What was that thing at the end? What was b? What did b do? It was the y-intercept. Turns out the y-intercept shifts things, numbers at the end, shift things up and down. So when we throw an extra number on the end, what happens to the original graph? It was shifted up 2. Let's write that down. Oh, come on, computer. That was weak. You don't talk to your computer? It was shifted up 2. So now, let's take a look. Let's draw a quick sketch of it and try to figure out where the asymptote is, right? If it was shifted up 2, then we're going to make a few markings, right? Shifted up 2, the original asymptote was at the x-axis, but because it's been shifted up 2, guess where it's going to be at? Yeah, man, it's going to be at the 2. Oh yeah, and the graph, if there was any doubt in your mind, still curves up. And it's exponential growth, so it's going to look something like that. What's the equation of the asymptote? Very nice. Let's play one more time and then we're out of here. One more time. The next graph, you see how it's -4? What happened to it? Yeah, shifted down by 4. Oh, computer. Computer. So weak. So weak. Yeah. It was shifted down 4. That's what that thing does. And so now, let's take this down. Let's draw it in here. Right, we're going to make some markings. 1, 2, 3, 4. Once again, these are just sketches. We're going to draw it in, right? It means the original was shifted down 4. So there's our asymptote. Now, which way is the graph going? Is it still going up? Still doing the same thing it used to do. It was just shifted down by 4. Nothing more to it. It's going to look like that. And what's the asymptote? Very nice.